those that are new, welcome. For those that are coming back, welcome back to my YouTube channel. Today we are going to be talking about matrices, and we are going to be solving simultaneous questions using the matrix method. Now, to use our matrix method, we are going to first need to split these equations up. We are going to create matrices. We're going to start with the one representing the coefficients, and then we will have one that is representing the variables, and then we have the one representing what we have on the other side of the equal sign. Now, so basically what you're going to start with is you are going to take note that the coefficient of x is 1. So I'm going to create three matrices. So I'm going to name the first one A, and this will represent the coefficient. So we will have 2, 1, 3, and -2. That is the coefficient, the matrix representing the coefficients. Then we will call the one representing the variables, we are going to call it x, and we are going to have our variables are x and y. Then we have the last one, which we are going to name b, and that will represent what we have on the other side of the equal sign. So it's 8 and -3. So we are creating matrices, taking information from our equations. So after that, we will need to now find what we call our determinant, because we will need to find the inverse of this. But to get the inverse, we need the determinant of A. And to get the determinant of any matrix, which we denote by writing it like that, we are going to call that the determinant of A is found by multiplying this 2 and -2. So we always say this times that. So remember, there's a law that says if I have a matrix that is consisting of A, maybe B, C, and D, then I know that the determinant of A will be A times D, which is just AD minus CB. So it's just cross multiplying, but then that minus the other one. So the determinant of A will be that. So we are basically going to do that. So we are going to say 2 times -2, and then we are going to minus 1 times 3. And that is going to give us -4 minus 3, which gives us a -7. So we have our -7 as a determinant. So remember, first we create our matrices from our equations, then we get our determinant. From the determinant, we are going to use our determinant to get the inverse. So what is the inverse? We are going to get the inverse of this main one, which represents the coefficient. So we are going to say our inverse, which we denote by A, and then that, we denote it by that. Our inverse will be equal to 1 over the determinant. So we always do that to get an inverse. 1 over the determinant times, we go back to the matrix we want to use, and we are going to swap these two. So this 2 will now be this -2, and then this -2 becomes that 2. So we are basically going to swap them. And then this one, don't change the position, but they just change the signs. Meaning, if it was positive, it becomes negative. If this was negative, it becomes positive. So now that they were both positive, they are now going to become negative. Take note that when we have, if we want to find the inverse of this A now, this A, what we are going to do is we will say 1 over the determinant times D goes to where A is, A goes to where D is, and C will become negative. D also, B also becomes negative. So that's basically what we should take note of. That's how we find our inverse of a matrix. Now we have that, so we are going to replace, because now we know what the determinant is, right? So we are going to say the determinant is -7. So that's what we basically have. That is A is equal to, now we multiply each number by -1 over 7, because this is basically just gonna be a -1 over 7 times this matrix. That's what we have. So I'm going to say, okay, what is -1 over 7 times 2? That is going to be a +2 over 7. Then I'm going to say, now what is a -1 over 7 times 3? That is going to be a +3 over 7. What is a -1 over 7 times? Basically, we are multiplying this number with each to create a new matrix, which we are going to call our inverse of A. So we are going to say a -1 over 7 times -1 is just a +1 over 7, and a -1 over 7 times 2 is a -2 over 7. So we have our inverse. Now we got our inverse, so we are going to now use our inverse to get our coefficients. But how do we use our inverse? What we have now, what we are going to do is we are going to say x will be equal to the inverse of a times the b. That's the formula we are going to use to get our coefficients. How do we use that? Remember, x is still a matrix that represents the variables, and the b is what we had over on the other side of the equal sign for each of those equations. So I have to use this formula to get my x and y. Now I'm just going to substitute. I know that x represents x and y, and then I got my inverse. It was 2 over 7 and a 3 over 7, 1 over 7, and a negative 2 over 7. Now I have that, so I'm going to continue that on top. I'm going to rewrite that. What we have after we use now this formula, because this is the formula that we are going to be using every time you want to find or use the matrix method to solve for the simultaneous equations. You always use that formula. So we are going to rewrite that just so that we can continue from there. We said our inverse was this 2 over 7 and a 3 over 7 and a 1 over 7 and a negative 2 over 7. So we have that as our inverse. Now remember, we need to multiply this with b. And what was b? B was the set containing 8 and negative 3. Okay, now to multiply, remember, we are going to say it's going to be a 2 over 7. So this xy is going to be equal to 2 over 7 times 8 plus 3 over 7 times negative 3. That's how we multiply matrices, right? This times that plus this times that. And then at the bottom we will have this times that, 1 over 7 times 8 plus negative 2 over 7, negative 2 over 7 times negative 3. That's basically what we are going to be having. What is that equal to? That gives 2 over 7 times 8 gives us 16 over 7. A positive 3 over 7 times negative 3 over 7 gives us a negative 9 over 7. And at the bottom we have 1 over 7 times 8 gives us 8 over 7. And then negative, this it's going to be plus negative 2 over 7 times negative. Negative times negative gives us positive, so we have a positive 6 over 7. Now we're going to continue there just to make sure we're doing step by step. Now that our denominators are the same, we basically have a 16 minus 9. 16 minus 9 gives us 7, so we have 7 over 7. Then here we have 8 plus 6 is going to give us 14 over 7. And we can see that there, basically what we are going to be having at the end is x, y is equal to, we know 7 over 7 is just 1, and 14 over 7 is 2. And that means then, therefore, we can conclude that x is equal to 1 and y is equal to 2. So that's our solution to this. Go back, pause the video, then you try to do it by yourself. Make sure you know how to find your determinant. Make sure you know how to find your inverse. And remember, we said the inverse. I'm going to go through just to summarize our formulas and just to take note of our formulas. Remember that we said if we have our matrix that has A, B, C, and D. Let me say this perhaps is negative. I can work with whatever I want. But if I want to get the determinant of A, which is denoted by this in matrix, means determinant, or they could say find the determinant of A, what I'm going to do is I'm going to say A times D minus a C times negative B to get the determinant. Then to get the inverse of A, which is denoted by this, I'm going to say 1 over the determinant, meaning to get the inverse, I should be able to get the determinant because I must say 1 over the determinant. Then I must now multiply with, I change A and B, so I mean A and D. So A will now become, or take the place of of D, while this C and B stays the same, but if it was negative, it becomes positive. If it was positive, it becomes negative. So I'm going to multiply these with that. I should just take note, these two, I swap them with their signs. If they are negative, I should swap them with their signs. Then these two, I'm just going to keep them there, but they change their signs. So I'm going to multiply that with 1 over the determinant to get the inverse. And the last thing is, when you are solving now for your simultaneous equation using the matrix method, what you do is you need to make sure that you get your matrix A, your matrix X, which represents the variables that you are looking at, and then your matrix B, which is going to be representing what you had as your answer, or what the answers that you were given. And that I'm going to use the formula X, which of course represents the matrix which consists of the variables which you want to find, is going to be equal to, now I'm going to say it's the inverse that you find times the matrix B, which you had as your answer. This is what you're going to use to get to your variables. In the end, you have X, which is XY, maybe A, B, doesn't matter what the variables are, equal to a number on top and another at the bottom. Then you just equate the top, equate the bottom to get your final answer to the variables. That's basically it.